Okay. We started by trying to rearrange this, or solve this equation, which we do by rearranging it into exponential form. And people weren't real quick at doing this. Now, I did comment that if you did everything that you were asked to and got good enough at it, you had plenty of problems to practice on, you would have been able to do this almost instantly. But people weren't able to do it. One person was. So first we went to this. And people actually did fairly well with this. A lot of people were writing this out and then identifying B, C, and X, as we did last time, and I'm not going to re-explain it. Yeah, you can refer back. So if we do this with this equation, we end up seeing that the equation rearranges to 3 to the second power equals x minus 4, which is how I look at it. I don't do this. And once you get used to this process, you start seeing how to look at the expression and rearrange it. But you always need to go back to this process to be sure that you have it right. Okay, well, this equation is easy to solve. This is just 9 equals x minus 4, and you can solve that in your head. Add 4 to both sides, you get x equals 13. Log base 3 of 13 minus 4 is log base 3 of 9, which is 2 if you understand the log base 3. Okay, and you know, maybe a little shaky in understanding that last part of it, but that's okay, because you can always solve this equation. Okay, you can solve this equation too. Okay, this then rearranges this in the same way to 3 raised to the 27th equals x squared minus 4x minus 12. Now 3 to the 27th happens to be a big long number. Okay, it's roughly 13 digits long. But what you have to realize when you see this equation is that it's a quadratic equation. It can be put in the form x squared minus 4x minus 12 minus 3 to the 27th. And you could figure out negative 12 minus 3 to the 27th. You know, it's going to be a big number. And then you plug this into the quadratic formula. Okay. Now we get to this equation. Log base 3 of one expression plus log base 3 of another expression equals 2. And we did pretty well with this. But when we first started, nobody knew, and nobody would be expected to know, because it's not part of the prerequisite courses, just what to do with this. So we've digressed and we've introduced these laws. Well, we don't have to introduce this. Laws of exponents, a to the x times a to the y equals a to the x plus y. A to the b raised to the c is a to the b times c. You should not only understand those laws and know them and know how to use them, you should know by simple examples exactly why they work. In any case, the log base b is inverse function to the b to the x function, isn't it? So the logs are inverse to power exponential functions, and you know, these are basically exponential functions here. Without going into the details, this law corresponds to this law, which says that log base b of m times n is log base b of m plus log base b of n. Now the MCR videos, we go into more detail in explaining the relationships, but there's the law. It's analogous to this because you see that we have a multiplication here that results in an addition of exponents, and the logarithms are just the exponents. And this law, which is just the flip side of this one. Okay, so you need to look at these laws, and the laws they're analogous to. It makes it easier to remember them, but not something people have a lot of trouble remembering if they practice sufficiently. So all I can say is practice it sufficiently. People learn this if they practice it sufficiently. It's not that difficult. So now we have this equation. What can we do? Well, we have log base 3 of one expression plus log base 3 of another, and that's exactly what we have here. Log base b of m plus log base b of n. So, you know, m is this expression, n is this expression, and the base is 3. That's got to be equal to this. So we can write the sum of these logs as the log of the product of these things. That's what this thing is telling you. Having written it that way, we easily rearrange it, that this is going to be 3 to the second, or go through this process, but be able to do it quickly, practice it until you can do it, you know, without having to think too hard. We get this equation, which is easy to solve. Okay, 3 squared is 29. If you expand this and subtract, or 3 squared is 9. If you expand this and subtract 9 from both sides, you get this. A quadratic, you recognize this as something that's going to be a quadratic equation. You put it in this form, you apply the quadratic formula, and you get your solutions. That's all there is to it. Okay, now let's consider this equation. Okay, we got something a little different here because we don't have just a log base b of m plus log base b of n. We have a 2 log base b of something and a log base b of something else. What are we going to do about that 2? Well, the second rule tells us, second property of logarithms, whatever you want to call it. Okay? It tells us that, okay, well, this is n times log base b of m. It's a number times a log. And this essentially tells you, well, you know, if you want to apply the rule for this thing, n has to be 2, and it's log base 5, so b is 5, and m is your x. Then you translate that over here, that becomes log 5 of x to the m, of our log 5 of x squared. So that's what we have, and here are the steps. So that this becomes log base 5 of x squared plus log base 5 of 3 plus x equals 2. And then the sum of these logs becomes the log of the product of the quantities. So we have, from the first law, our first property, first rule, this becomes log base 5 of x squared times the quantity 3 plus x. And that's still equal to 2. We translate that to exponential form. We get x squared times 3 plus x equals 5 squared, which is 25. Okay? And we get this. Okay? X squared plus 3x squared minus 25 equals 0. We can't factor that. Okay? The factor is going to be irrational. There is a formula for solving a cubic. This isn't a quadratic equation, so we don't even have the quadratic formula. We can't solve this exactly unless we go to the whole set of calculations we have to do to solve a cubic that nobody bothers to do anymore. Because we have graphing calculators. To solve this is the first valid application we have of a graphing calculator. We would graph y equals x squared plus x cubed plus 3x squared minus 25. And then we would find the zeros of that graph, which are the values of x for which this is equal to 0, and those would be your solutions. So, we're not going to go to that at this point, but that is how you would end up solving this. But this is how you get this into an equation that you can write out in this form and at least begin to deal with.